Okay, so today I'm going to talk about the graphics lies and misleading visuals. This is based upon a paper by Alberto Cairo. He's done a lot of great work in pointing out how we misuse data visuals to oftentimes lead people astray. And this kind of reminds me of a quote that I heard from one of the professors at UW Bothell. It says, "Without data, you're just another person with an opinion." And this is from Dr. Angotti. And the point is that we use data oftentimes to provide evidence of the claims that we're making, right? And without evidence of the claims that we're making, they're claims without evidence. They're opinions. So what we want to do is make sure that we appropriately use data in order to inform the decisions we're making and to better support the arguments that we make when we're trying to bring a claim forward. So think about data visualizations as providing kind of a window into the evidence that's available for people. Now, the flip side of that is if you misuse and misrepresent the graphic, misrepresent the data, then you're falsifying the claims. You're not using them in the way that speaks to their truth. So to kind of again kind of come back to this idea that data visualizations are simplified, purposeful representations. They're usually designed, they're usually made by somebody, and there's usually an intent behind that. So if you think about that, then they're artifacts of whoever made them. And oftentimes they're hidden agendas or maybe even, kind of ways that you hide data. And so we'll talk about that as some of the common ways that data are misused. So probably the most three common ways that data visualizations are used to mislead an audience are hiding data, displaying too much data, or using graphic forms inappropriately. And I'll talk about examples of each of these from the reading. Okay, so how do you hide data? All right, so for instance, let's look at this graph and it says our sales have improved by 12% over the last year. So oftentimes you see advertisements like this where it's one single figure or one single number that exemplifies just how good things are. But if you were to zoom in and look at sale changes of our 10 main markets, right, you would realize that there's actually distribution of the markets. Some of them are doing really well and others are kind of going down. And so, when you hide data, when you kind of like average out all the mountains and valleys that exist within your data set, it oftentimes does a disservice to understanding what's actually happening behind the scenes with your data. So it's important to think about how disaggregation can tell a different story than the single like bullet point one number answer. Not to say that the 12% doesn't have value, but it's not the best way to use a data visualization if you're trying to tell a story or give people information from which to make a decision from. So the flip side of that, of hiding data, is oftentimes showing too much data. So here's another example that Cairo talks about. So oftentimes you might see these kind of maps of the US and they're colored in by different states. And you notice the one on the left has poverty rates and there's some nice gradations, right? It uses a grayscale from light to dark to show where poverty rates are. Now compare that to this one on the right that uses bubbles to represent how many people are below the poverty line. And this is a common problem with these kinds of maps, which is oftentimes they just show you the population centers inside the different states instead of actually giving you some kind of information about what's happening in a usefully aggregated way. So showing too much data is oftentimes a mistake that beginners make because they get excited that they can use the tools. They want to show everything. They want to take all the data points and plot them. And it's not a bad thing when you're learning. to figure out how those tools work. But the problem is that it's really difficult as somebody in the audience to understand how to unpack that. So you have to meet people where they are in terms of their visual literacy. And when you're designing these graphics, think about what are the big takeaways? How do you show the trends? How do you give them enough information they can make a decision from? So showing too much data oftentimes overloads somebody's uh, cognition, and they have a lot harder time engaging in the audience. And because there's so many barriers, it oftentimes hurts the visualization in the end, because people don't want to dedicate time to unpack things. They'd rather see something easy to understand. Now, another way that data is misused oftentimes in visualizations is using inappropriate forms. So one way to think about data visualization is, creating scales and mapping numbers onto a scale to show how much space is different. Now, one example of this comes from an election that happened. Nicolas Maduro won in 2013 by a narrow margin. But based upon this graphic, you would think, oh, this was a landslide. Look how much bigger the cylinder is for Maduro compared to his opposition. But if you look at the numbers, it's 50%, 50.66%, and 49.07%. So the margins are pretty small there. And I love that Cairo pointed this out, because what he did was he analyzed this and found what would it look like on an appropriate scale if these bar graphs were used appropriately. And this is what they would look like in terms of space, right? So now the scale is set with a 0 at the bottom, so that you get a sense of, everybody starting at the same place, everybody has an opportunity to rise. And wow, that is a really close race. If the numbers weren't there, it would be hard to tell which bar is the tallest, because, it's only a few pixels different. So that's one way that data graphics oftentimes get misused. And as a general rule, when you're doing comparisons like that, it's important to have a meaningful comparison to start. So setting things at 0% is oftentimes useful, although it's not a hard rule. Other times, like if you're looking at stock market and stuff like that, it doesn't really make sense to start the stock market at 0, because when was the last time anything was at 0? It's more important to see how it was relative to, the more recent highs and lows. All right, so using forms inappropriately is a big deal. So one thing to think about, and is that data visualization, oftentimes the first dimension you visualize on is spatialization. So you try and make things bigger or smaller, wider or thinner. So let's look at this for a comparison. So imagine that I'm looking at this this graph here. I have these 3 colors, purple, gray, and gold. And if I asked you which bar is 4 times bigger, you'd probably be able to answer this pretty quickly, right? This might not even be worth making a poll. Yeah, so I won't make one. But yeah, if somebody in the chat wants to say, which one is 4 times bigger than the purple bar? So just from the scale alone, you can see that there are smaller and medium and larger bars, and the gold one being the largest, right? Yeah, so it's 4 times bigger. And we know it's 4 times bigger because what we did was we scaled the height to be 4 times bigger, but we kept the width the same. So if you think about area as the way that our eyes kind of perceive which bar is bigger, we would have, the smallest purple one being a height of 1. And if the width is 1, then the area is 1. And then we could imagine kind of stacking 2 of those to make the gray one. And we could imagine stacking 2 of the gray ones to make a gold one. So altogether, we would say that the gold one is 4 times bigger. Now, this works really well when you're thinking about bar charts, because we kind of have a sense of how height works. You see it every day. Some things are taller than others. But what happens when we start to change the shape? Things get a little more tricky. So now let's do this again. Imagine this little purple circle, and I have my silver and my gold bars are now circles as well. So which one is 4 times bigger than the purple circle? Okay, going to guess the gold one again. Yeah. So you can kind of imagine those purple ones being like set side by side, right? And you could fit 4 purple circles in there. Gregory says gray, silver. Okay. Yeah, so let's do the same kind of math here. So again, if I focus on area of a circle is pi times the radius squared. So if I make the radius double or quadruple, make it twice as big or 4 times as big, the area actually ends up being square that much. So from the purple one to the gray, I now have an area of 4 pi. So even though I've only increased one dimension of my circle, the radius, the area of it is 4 times bigger. So that's one way to think about it, is that depending on which direction you're moving and increasing your scales, you're going to get a different effect on the object that you're looking at. So one of the uses of data is by trying to change these dimensions in more than one way, and it creates a disproportionate increase in the space that you're visualizing something. So even though this radius, you might say, well, I've only increased my radius 4 times, so it should work, right? It should be a proportionate scale. But because of that square in the radius, I've now have an area of 16 times bigger. And if you start thinking about spheres, that they work on a cube scale. So now you're going up even more and more. So think about what kind of object you want to use and how you're going to show the difference between the scales using this spatial form. Okay, so continuing on this theme, let's talk about some other ways that using graphics can be done inappropriately. This was an article that said the World Wide Web is dying based on the graphic. So if you looked at the total internet traffic in the US, it looks like, we had this really big increase in people using web browsers and peaking over 50% in the year 2000. And now in 2010, it shrunk down to 25%. Meanwhile, the other ways of accessing the internet have gone up in those last 10 years. So just on this figure alone, it shows you kind of proportions of different uses. And you would draw the conclusion that, oh, web browsers are actually, going out of style, that people aren't using them anymore. Now, let's look at this a different way. So if instead of looking at proportions, I just looked at the count of the internet traffic, right? And specifically how many bytes there are of traffic. And what you see is actually these are both exponential curves going up, and the web browsers are higher than they've ever been. But also the other forms of accessing the internet have increased tremendously too. So, thinking about the proportions kind of does a disservice to showing the broader trend. And it's important whenever you're trying to visualize something to think about it in terms of proportions or in terms of counts, because they can give you completely different messages, right? Depending on how you visualize that. And we have a little activity today we'll play with for that. So those are some of the ways that forms are misused or used inappropriately. But there are also things that we would say are used appropriately, but people can interpret things differently. So I want to point out that there's a distinction here. So in this case, they're using graphic forms to make an argument that isn't actually well supported by the data when you look at it a different way. Now, that's different than looking at the same data and agreeing that the data and the facts are solid, reliable, and then interpreting them differently. So I'm going to talk about an example that is kind of old now, but I think still pretty relevant. So during Obama's time as president, he got a lot of slack for having such a high unemployment rate. And if you look at this graph, it shows the unemployment rate over time, starting in 2006 and ending 2019. And as you can see, it goes up quite a bit. Now, the grayed out area, the shaded area, is his time in the office. So depending on which kind of political affiliation you have, right, which party you belong to, you might interpret this different ways. So I'm going to practice interpreting it to give you a sense of what different people saw when they looked at the data. Now, keep in mind, they all agreed on this data. It's just that the view is a little different. So first, let's make this figure a little bigger so we can get a better sense of it. And so starting at in 2006, unemployment was about 4.7%. And then recession hit, and we saw this huge increase, and it caught all the way up to about 10% unemployment increase. Now, we could probably make similar graphs for what happened during the coronavirus and the large unemployment rates. And then it slowly went back down to 4.7%. Now, critics of the president would point out that, we want to keep the unemployment rate below 6%. And most of Obama's tenure, the unemployment rate was above that threshold. And so, as you can see, if I were to kind of fill in the bar with this kind of highlighted area to show the area under the curve that's above 6%, they would say, well, most of this duration was above this threshold that was set. And, this is a big criticism that, during Obama's tenure, he didn't have an unemployment. He didn't bring unemployment down below an acceptable level. Now, allies of the president would actually view this chart a different way. They would instead focus on the rates. And in particular, you would see, even though the unemployment was going up, these things maybe were out of his control. And since he's been in office, the duration of his tenure has been bringing down the unemployment rate. So they're focusing on, things decreasing. And so both are supported by data. Both kind of interpretations are there. But again, kind of the perspective you want to take, the argument you want to take, can allow you to interpret the graph differently. And so it's important to understand that people might be looking at the same thing, but just interpreting it different ways. All right. Okay, so the next thing I want to talk about was a data visualization that kind of blew up Twitter, at least with the Twitter that I follow with the data visualization. So I want you to, take a second to look at this graph and then come to a conclusion about what it says and think about why is it that people were getting upset about this figure in particular. So go ahead and take a second to look. It's going to be, the title is Gun Deaths in Florida. And this is from a news article in Business Insider, but they're using data from the Florida Department of Law Enforcement. So this is the number of murders committed using firearms. So take a second, look at it. What stands out to you as you look at this? Hey, yeah, that was the big complaint that so many people had, because a lot of people would point to this and say, well, look, here we have this chart and it goes up. And then right here, the Florida enacts the stand your ground law. And it's like, oh, well, from here, all of a sudden these things go down. So this must be a good law for arguing that, this will prevent gun deaths. But it's actually the opposite, because this plot is flipped. So the designer of this used larger numbers down below and used the shaded area to show the area as it gets more red, there should be more deaths. And so having this upside down graph really messed with people, because everybody kind of saw the story that they wanted to see, but it didn't follow kind of the conventions that have been used for most line graphs. So it is a real challenge to try to be inventive in these areas, because some people have gotten used to expecting things to look a certain way. And hopefully by the reading that you read for next week, you'll start to see that there are ways to be inventive and to mix up the conventions. But you also want to be careful in thinking about what the viewer experience is, what the user of your graphic is going to come in with in terms of their conventions. And the other thing that's interesting about this is we almost always put timelines like this going from left to right, the past to more present. So doing things like that, moving left to right, is another convention where people might flip it and give you a totally different story than what you thought at first. Okay. One other thing, so that we talked about how breaking conventions can really disrupt the interpretation process. And I want to talk about one other thing, and that is ducks. So Edward Tufte, excuse me, talks about how he used to drive past this place, and it's a little stand, and I think they would sell like duck eggs or something like that. And in terms of architecture, you would say, well, this is putting form over function, right? Like, why do you need all of this extravagant plastering and siding to make it look like a duck? Isn't it just a little shack? Like, why don't you just have a little shack? But the bigger problem for data visuals is oftentimes people put so much focus on the form that they forget the function, right? So that they'll add a lot of extra kind of wingdings, so things that are distracting from the main purpose. And I'll show you an example of this. So Edward Tufte is a great book on data visualization if you want to read one, called the Visual Display of Information. Points out that one of the biggest problems in these data visualization fields is kind of the dramatization of data visuals, because they are, it's like the monstrous cost from chapter 1, because what they do is they distract from the main purpose. They create more of an illustrative figure than a data visual. Now, not to say that illustrated figures aren't valuable, they are, but when you're trying to blend accurately representing the data and creating an engaging visual, you should try to not sacrifice the purpose for making it catchy. So here's an example of one that I think you'll find agreeable as a mess. So this is a graph from kidsforcars.org. Cars is spelled with a K. And it says most common driver distractions, survey results by gender. And for whatever reason, they decided that, first off, they use a pie chart when there's way more categories than you could possibly visualize. But they try to show this as wheels of a car in a car crash. And for whatever reason, the men represent one car, women represent another car. And as you can see, it's really distracting from what the main purpose is. And you really have to zoom in to even see like what these categories are. So it becomes really difficult to interpret this. It's like at a glance, you can kind of see the story, but in terms of extracting information to make a decision from this, it's pretty horrendous. So this is what we would call a duck. So a duck is where you've prioritized style more than substance. You've prioritized the form over the function. And we want to avoid ducks because they might be a little gimmicky, but in the end, they don't really give justice to the data that you're trying to visualize. So, well, we'll keep moving on. So this is oftentimes called chark junk as well. And it can be dynamic. It can draw the audience in, but it usually comes at a pretty severe cost of undermining the usefulness of the data visual. And it's like, why are the wheels the thing to represent as a pie chart? You know, like it's just, it's kind of like forcing your data visual to be a part of an illustration. Yeah.